This is my presentation on Lab 2 on charge tapes part 2. The main purpose of this lab is to understand excess charge on matter and how that charged matter interacts with surroundings. The main thing that changes with this lab is that we also consider how object consideration can change the electric field. So we'll be talking about point charges versus line charges and their effects on the electric field. So some physics concepts in this lab include electric field, electric force, uniform distribution of charge, conservation of charge, conductors and insulators, and charge interactions. So as a quick throwback to the first experiment, I included some pictures of that experiment, like interacting charge tape with stuff like my hand, another piece of U-tape, and a negatively charged pen. And some original values and calculations that I included was length of piece of tape, the mass of a piece of tape, the distance between the two tapes when began to float above one another, the magnitude of the gravitational force on a piece of tape, and the magnitude of electric force on a floating piece of tape. Some other calculations I include from part 1 that aren't extremely important are excess electrons and the ratio of excess electrons to surface atoms. And I included this mainly because it is a calculation that uses the tape charge from the previous lab and a computer model from it. And that's really important for the calculations that we'll be doing in the upcoming lab. So to better model how a line charge works, I created a coding model that starts with initial values like the electric constant, gravitational constant, mass, the Q from the previous lab. I use the same function of E field from the last lab to be able to calculate electric field for a specific point charge or charge particle. And I also use variables found for previous lab. I use a function for a line charge, which creates an object for n uniform point charges, and use that to create a top tape and a bottom tape object. So for our coding model, we also included a nested loop, and the top loop has an initial electric field and it initializes the arrow, but the inner loop calculates the electric field for each n charge, kind of like a dE with a dQ charge, and it adds that up. And this is pretty much the same thing when calculating the electric force as well. And it helps with adding up the arrow for that as well. And after all of that, we create an object of electric force arrow and a gravitational force arrow. And for this right here, we see that there are green arrows represent electric field, white arrows for electric force, and a yellow for gravitational force. We said this is for n equals 5 point charges, and these following two pictures are n equals 100 point charges and 10 point charges, and that this shows what it looks like for calculating that electric field and how far out that it can expand to. So some final questions are, if I had modeled each of the tapes as a single point charge like in the previous lab, what would that look like? And my main results from what I wrote down here was that the single point charge seemed to have a much larger but less accurate electric force compared to the line charge. And for why these estimates differ, I said they differ because the line charge has more point charges that are considered in its calculation, and the line charge is more accurate to the real value because it considers a more uniform distribution of charge compared to the original point charge. So some conclusions for this lab are that due to the superposition principle, treating the tape as a line charge is more accurate than treating it as a single point charge. So the more n charges on the tape, the more accurate the electric field and electric force. The main assumption that we made was that each piece of U-tape has the same amount of charge evenly distributed across the tape. And lastly, the computational model helped to represent the multiple electric fields evenly on the tape.